So just a few days ago, I was able to coordinate and get together Don Syme, right, lead language designer, inventor of F sharp, and Guido van Rossum, and Don spent some time teaching Guido a little bit about F sharp. Let me play the video, and let's catch up and see how it goes. Hey friends, my name's Jeff Fritz, and I'm here with a couple of my colleagues so we can learn a little bit more about F sharp. Let me bring them in here. I've got Don Syme, Guido van Rossum here, and we're going to learn a little bit more about F sharp from gosh, Don, who's lead language designer for F sharp, and we've got Guido, who's the language designer for Python. Welcome in, guys. How's it going?
Hello, Jeff. Thank you for having us on the show. It is a real privilege to be here today.
Hi, Jeff. Yeah, looking forward to it.
So I understand a lot of folks, they want to go through that beginner process. They want to learn about F sharp, and what better way to go through and learn that those first steps to get started with F sharp for other folks who know other languages than, gosh, to see two language designers go through this together. I think this is a really great idea.
Jeff, I am so honored that Guido agreed to do this, but in fact came up with the idea and the format. I think he is setting a wonderful precedent for language designers worldwide and for into the future to say, hey, something new, something different. Let's take a look at it.
I need to give credit for the idea to Steve Holden, who once, many years ago at a Python conference, held a session that was Teach Me Django, and he actually let the audience teach him Django. It was very entertaining.
This is how we learn. Step outside of our comfort zone, try something different, and hopefully have a good time with it. So, gosh, I'll let the two of you go to it, and I'll just be here in the background if you need me.
All right, that's great. Guido, all set for a session of learning. Don teaches Guido some F sharp. So all set?
Yeah, I'm all set. I have tried not to read anything about F sharp in the last 2 months.
Okay, coming at it
so
clean, coming at it fresh. That's great. Now, today, the material we're going to be going through, I will share my screen, is at github.com/dsyme, and it is Guido Learns F sharp is a repository. Now, we have done a little bit of setup for this just in the 5 minutes before we started, and Guido has cloned this repository and pulled the latest changes to it. And there is also a guide in the repository, a guide.pdf, and Guido has also done the installation of the prerequisites, which is the .NET Core SDK, Node, VS Code, and the F sharp extension for VS Code. Running through those steps quickly to orient those following along, please do, if you're following this, please feel free to kind of pause the video as you go along, do the tasks, and then compare as we go along. And so there's the repo that we've got. There's one of the setup steps to the .NET SDK. Guido has promised the .NET team some feedback on their installation page for whether he found some things that need to be fixed. And that's all the way along when you're doing this kind of dojo. Those are the kind of things you fix and you notice, and as you work together, you kind of make these experiences much smoother and much more intuitive. You also will want to install Node.js and NPM. And some of you might be thinking, I'm installing Node. Why am I doing that? F sharp is a .NET language, but F sharp is also a JavaScript language. And we will be using it as both a JavaScript and .NET language in the sample today. You are installing VS Code. Some people in the past have accidentally installed VS Code by snap. Don't do that. Install it just the way it comes. And you will also be installing the F sharp support for VS Code. You'll probably get an automatic prompt for this if you don't do it yourself, the ini.f sharp package. And we are now going to dive straight in. I'm going to close my screen, and Guido is... click the stop sharing, and I will Guido will share his screen. Okay, so we got VS Code open, and the pre-steps that were necessary were to do .NET, to go to the repository directory and then do .NET tool restore, and then .NET run. And that restores the projects, gets the dependency chains, and then runs the application that we're going to be building. And Guido, I think you have a browser window there with a just sized quite nicely to fit down the right-hand side. Okay, we are now running so the way this is going to work, just to give the format, is it's a dojo. And Guido learns F# are a dojo. And in fact, it is a set, so we'll do a set of tasks, and then we will land Guido in the middle of an application, which has been sort of left in a half-finished state by someone who was trying to help him out, but didn't really work out that way. And Guido's got to fix a lot of things with this application. And they're grouped in 5 clusters, 4 main clusters, and then one is a bit different at the end. And but the application does compile, and it does run. So and it's actually a client-server application, a web app with a server backend. And Guido, if you do the magic URL for accessing the locally running one, and not that one, and localhost. Here we have the application running, and I have heard, one reason we're pre-recording this, so Guido is having the amazing good fortune in 2021 to actually travel. And in fact, I've heard you're taking a trip back home to Europe. Is that right, Guido?
That is correct.
Well,
we'll see about the good fortune.
I understand.
I've been bombarded with emails reminding me of all the COVID precautions.
I see. Yes. Well, this. So someone was helping out Guido with his app for his trip to Europe. It doesn't cover any COVID dimensions. There will be only one small mention of COVID in this whole exercise, and so someone has been trying to help out Guido. Let's see how this app rocks to start with. So you can give the app a try. It's actually asking for a postcode. And it's asking, I know you are originally from the Netherlands, one of my favorite countries in the world. And you can type in any Dutch postcode you wish and see what you get. Okay, and you can hit fetch. That's it. So you actually you're not the return. You can just click on fetch. Yep. And
I have no idea of the distribution of Dutch postcode, so I'm just going to enter something random.
Did you click on fetch there, Guido?
For the first one, I did.
No, okay, we've got a problem of some kind. No, I think you didn't click on. Okay, great.
Maybe I didn't click. Haarlem.
Heart attack moment Haarlem, when it wasn't. I thought it wasn't working, but it is. All right, that's grand. And feel free to put in a second stop here.
From Haarlem to Amsterdam. How appropriate.
That's absolutely great. Okay, so the app is in a kind of half-working state. And now helpfully the person who left this app kind of half-finished did leave some notes about where things needed to be done in the code. So we're going to be using the search all code, the magnifying glass on the top left, or feel free to use all your favorite keystrokes. I know you're a VS Code user regularly in your Python programming, if I understand. So all the usual searching and should work just fine. And you can search for the word task. Yeah, no, not capital, and make it a capital T on the task, and may as well put on a whole word and whole and capitalization just to get us down. And you can scroll down there and we can see a list of tasks that will need to be done. And fine. Okay, great. And we can, in fact, start with task 1.1. Now that's the one in the README. So if you actually scroll down to the one in the code, I'm not sure why it's saying, yes, that's just saying you will do that. And we can start with task 1.1. Okay, so they've left a note saying the text is wrong. What is this tooth stop business in the app? Now, it's not a major bug in trip planning, but it is big enough that we want to kind of fix that.
You want me to try something? Well, can I just start typing because this looks easy enough?
You can just start typing. Now, I do know that Guido has some experience with Haskell and is fully conversant with the idea of pattern matching, like all programming language designers these days are.
Well, we're introducing them in Python too, actually.
That is absolutely wonderful to hear. We are infecting the world. I love that. So if you can save that file now, that would be great.
Isn't it? Okay, for me it's usually set on autosave, but that seems project specific or something.
Okay, so
Something
first task
saved.
is fixed. We have second over on the right.
Oh.
So we have a hot reload
Okay.
experience in this development experience, which is looking good. So feel free to pop in a few more. We'll probably do no more than 4 stops today to test things out. That's absolutely fine. Third stop.
Okay, it does actually. Where is 7,000? Oh, I guess enter doesn't work yet. Try another postcode. Okay.
That means you got a validation error on the server side.
Try another postcode. Yeah. Okay.
Feel free to use the browser to look one up if you wish. You can use 1011 if you like.
Ah. Third stop, Tessel.
Okay,
Excellent.
That's looking good. Okay, and we've still got the fourth. The fourth is looking okay. In fact, after we don't need to fill in fourth.
Yeah, no, I'm just gonna fix the layout there.
Yeah, lovely, excellent. Even learning how to format F# code. That is excellent. Okay, task 1.1 is done. That's great. Let's move on to task.
Oh, that is, huh?
2. Yeah, but these start nice and simple, and you can take a look there. Just two things above. That's it. Task 1.2. It's great. Yeah, that's very helpful.
Okay.
Okay. Now I think make the probably make the search box on the left a little bit narrower so we can see a bit more of the code. I think you can narrow that down until we see that.
Yeah,
that's it. And if it's possible, I don't know if it's easy to hide that bar down the right, that changes bar.
I have no idea. Yeah,
okay.
I once knew, but we can make an excursion to configuration.
Yeah, that's fine. Okay. Then maybe make the code one thing smaller so you can see your application and the
like that.
Yes, and now over on the right, make that we can see the application at the same time as developing the code. Since we'll be doing a lot of hot reloading, yeah, that's looking perfect. Yeah.
It looks like I can make that quite a bit narrower.
Yeah, you can. That's right. Okay, so task 1.2. Now, I'd like to take a moment to orient yourself on where you are and seem to understand what part of the application you're actually developing here. So if you just scroll up until you see the let on line 252, it says let location display, and taking a location response as an argument, and we use equals. And then it equals, let's say, a table, a t-body, a tr, a th, a td, a tr, a th, all the way down. And you can see this is actually an HTML DSL in the web application. So this is sort of generating HTML programmatically. And you can see let's check out the correspondence. So if you see the line th region, so this is the string region. In fact, you can edit that to something else if you like, just some random text, and save. Then over on the right, you'll see the exclamation mark. So you can see where we are in the visuals in terms of that's the header of the table column. And now we want to fill in this to do here. And we need to find the region. And it does give you a hint. You might fill in the region found in the location response. Replace a string to do with, for example, you can see the location response that we have. LR location response is the argument.
Okay, let's lead. You've been talking a lot, and I'm trying to read what we're going to do here. I should have warned you that I'm not a web developer, so
it's fine. You are today.
I'm like, oh dear, do I still know how tables work in HTML? Because that was a while ago.
Yeah.
So what we're looking, we have LR, which is a location response, and there is LR.location. Okay, if I just put LR.location, like the comment says, location. Okay, if I type that in lowercase, it'll
cool.
Whatever autofill will still do that correct. Then hit dot for the region. Oh, yeah, I had hit tab, not return. Okay.
Yeah, that's the one.
And let's see what happens when we save North Holland. Yeah, it's all North Holland.
Everybody's just in North Holland. That's right. We don't know the postcode for Maastricht or one of the places in the south. Excellent. You've successfully become a web developer today, Guido, filling in content in an HTML DSL. So I
guess we go on to task 1.3a.
That's correct. We can go on to 1.3a. Okay, we have our only mention of COVID for the day, which is that we have distance to Heathrow. Now, as you know, COVID is running rampant here at the moment, and you do not want to fly to Heathrow. I can be sure maybe you're passing through. I don't know, but I think you'll be flying to Schiphol, which is...
In fact, I did manage to find a direct flight. Lucky us.
All right, indeed. Lucky. So,
but that changing the text doesn't suddenly make it change.
No,
so where do we find?
Correct. So save the text. That's right. And
still save that. Okay.
Yeah, just keep saving. Save off.
Yeah, but now it's much more obviously wrong.
Exactly. Nowhere. Nowhere.
What I remember of Dutch geography.
Probably nowhere in Holland is that far from Schiphol. Maybe it's right at the top right. I'm not sure.
No, maybe Maastricht.
Okay, so this thing distance to airport is wrong in some way, and we can actually search for. You can actually either. It's up to you. You can actually search for distance to airport if you like, or you can search. So you can see. Helpful. Yeah, so you can see the text. The number is coming from lr.distance to airport, and you can do a search for distance to airport. That's fine. Or you can actually do a right-click, go to definition, and on the search, could you put case sensitivity on, just so we get the actual.
I always forget which one. Okay, there's that.
And you can put on whole word as well. We won't want to do partial searches. That's right. Okay, so let's take a look in shared.fs. In the search list down the left, you'll see there are 3 results in the search for distance to airport. One of them is in index.fs, or 2 of them are in index.fs. One is in api.fs, and one is in shared.fs. Let's take a look at shared. This one here. This is the definition of the type, which is the location response coming back.
Okay.
Okay, and now
looks like a dictionary to me.
Yep, that's right. It's just a dictionary record type, and that's right. Now we're looking at api.fs. If we take a glance there, we will see the distance to airport being calculated. In fact, you can see it being calculated here.
So there's a reference to London.
That's right. Now to change, that's here.
Oh.
For this one, I'd like you to do a right-click rename symbol on London, just so we start using.
Oh, we're going to actually use refactoring.
Oh yes, you're going to do refactoring. That's it.
I hate that, but sure.
That's okay. Shipol, it's good. And,
it's still it's probably loading the code for refactoring because I've never used that in my life.
Yeah, good.
But there it is.
And you can now save that as you save as often as you want. I'm a bit of a saveaholic. Always saving my code.
Sure, but we didn't change the let long. So
exactly, task 1.3c, exactly.
Let's just Google that.
That's right.
And let's hope that Google just used decimal fractions. Okay, go back to this thing. Save.
That's right. Now,
okay, that didn't actually.
Yes. Now you will have to make a new request over on the right. You'll have to, for instance, reload the page and enter some data. This is because you just changed the server part of the application, and you have to reload over on the client side and re-enter the postcodes.
I see. I see.
That's it. And you can hit
and I never hit fetch for anything. So
yeah, we have independent fetch buttons. Yeah, that's right. All right. So, I think the distance to Schiphol is looking pretty good there.
Yeah, I don't know what happened to Haarlem, but try that. Yeah. Okay. Here we go.
Okay, 12 kilometers. I love it. Okay, that is great. And now we fixed the distance to airport. We've got rid of the references to Heathrow and London, and that is great.
All the impressive stuff here is done by databases that apparently know zip codes. All right.
Yes, we are using a web service that knows a zip code, absolutely. And I can dig into that in just a moment. Let's finish off on task 1.4 and then have a chat about the architecture that's being used and the mode of programming and some of the language features we've been seeing along the way.
Okay, some error.
Okay, we will dig into this in a bit, but try an incorrect postcode of some kind over on the right and half completed. All right, now it is saying invalid postcode there, and it is saying it in green, and that is obviously not the color we want to use here. We'll just fix a color here, but the actual what we're going to be coming back to is actually
your audience is not going to be able to read that, but
it says invalid postcode. That's right. And so if we just change this to the danger color is danger, and save. But
I see.
Yeah. Danger.
You actually have a sort of a little enum of various colors, or I don't know what it is. Is it an enum? Is it a structure? Oh,
it's a generated API.
Okay.
Yeah. So
it did automatically refresh when I saved there.
Yeah, that is great. So that is our initial set of tasks, and that is absolutely wonderful that we've been going through those. Now I will. We'll talk about some of the things that we've seen along the way. And I just want to walk through some of the things we've seen along the way. And the first is that so much of F# programming is let. You saw the let function definitions we were doing. You saw the let Schiphol for defining let London equals finding
in
data.
fact, it's so ubiquitous that I don't remember even seeing it.
Yeah, that's right. It is just absolutely everywhere, and there's a let.
There's one.
Yeah. And or a little bit. The first function you defined was this adjective thing. And so that's defining a function. You use let to define data. Now, in Python, of course, you don't have let at all, but you're just doing a very similar kind of thing. You've got your defs for some kind of things, and the values don't actually use let. But actually, and we'll be looking at an example later on of if you just take F# code and strip out the lets, you often get very close to Python code. It's a very similar mentality between the languages, I think, which is it's about defining some values, about defining some data, and then working with them. And that has been the fundamental mode of programming for. This might be a little bit more oriented around defining functions to work with things, but still, it's just let all the way through. The next thing, language construct you saw is match, and that was the very first thing we saw. And as you're familiar with pattern matching, you just take an expression and then match it against various patterns. It's a it's an absolutely core construct in F#. It is just forms so much of how you do decomposition of data and then taking various cases through. There is an if then else. You use it for Boolean values, but besides that, match is kind of the way you take different parts in your code very often.
That's going to be an interesting direction we're taking in Python. We just in 3.10 we're introducing that, and it's going to be interesting to see how much of the Python community will actually switch to using match, and to what extent people will just keep picking things apart using if then else.
Yep, I understand.
Like they've been doing for 30 years.
Yep. And C# is in a very similar position. It's put in actually a very rich form of pattern matching. There are even a couple of things that they've done, which we will include back into F#. And there's some things we definitely won't include back into F#. That would be a longer conversation. I'd be happy to have that conversation with you about Python as well from my experience. But it is absolutely fascinating to see these languages bringing in these features and how that kind of changes the kind of development side of things. There was another use of match further down in task 1.4, which is showing in your search bar on the left. If you just want to double click on that, it's just further down in that file. And this was this, you can see a different pattern match saying, when we're displaying the help text, check if there's a validation error. And if you hover over validation error, you'll see its type. And it says it's a string, an option of string. Okay, so options you match with none or some, just like in Haskell and many other languages. And and if there is no validation error, then we don't generate anything. And if there was a validation error, then we show the text, prop.text on line 348, and we set the color to danger. Okay, so this is even when we're generating HTML, and we'll get back to this in a little bit more after task 2, even when we're kind of generating these structures, DOMs, we use pattern matching to work out what we're generating.
I'm actually confused about what's happening in the sum error case. I understand what the sum error part does just fine, because that's like matching a pattern sum with a that has an attribute error, but I don't understand what the color.isDanger and prop.text error do. Is that things with side effects, or is that still part of your mini HTML? DSL?
We will be talking more about this in. Okay. It's a general construct called computed lists. So if you look at on line 338, the help that you've got there, the kind of help and then the square bracket. It is generating a list, either empty list or a list with 2 elements. And so
this is exactly like a very fancy generator.
Yes. It is like comprehensions or generators on steroids, and it is a really powerful construct in F#. And if you actually look through this file, and we'll be talking more about this in a moment, or we can talk about it now.
I suppose
your language design eye spots this immediately. It is one of the most powerful constructs in F#, and it is incredibly good for generating data lists of all sorts of crazy shapes and sizes. And
so is it? Yeah, I see. Is this help? Is that just an attribute on a property?
Help. I think if you just hover over help, I'm actually not. This thing is generating a help React element. So one of the standard React elements for CSS and everything else is help. And so we're just generating some help, and then the CSS will look after how that gets.
Wow, something in Spanish showed up there. Full name: Feliz Bulma help.
We have some great members of the Spanish community. That's actually a really good place to segue into section 2, where Spain does appear. But before you do that, we just run through the lessons from on the slides over on the right, just to cover all of those. One of the other things you saw was dot notation. And so F#, you saw lr.location.response. You just saw it supports
feels very similar.
It feels similar. It's funny. It feels similar to C# in that it is static. Those property resolutions are static. They're not dynamic property bags. Like in Python, it is static resolution of the dot notation. Because F# is a statically typed language, and in fact, that difference between dynamic property bags and static.
What is this bag word you're using? That sounds like pejorative. That's probably just sort of functional language lingo, but I don't know what a bag is.
When I say property bag, it is just a technical term, meaning a dictionary.
Okay, yeah. I guess F# people are more familiar with the term property bag.
Yeah,
but I have not heard that one before. Okay.
Okay. In fact, they're probably using the term incorrectly, actually. So let's just call it a dictionary with either static keys or dynamic keys. If a dictionary has static keys in F#, it's called a record.
Okay.
If it has dynamic keys, it's called a dictionary.
Mm-hmm.
But we won't be using dynamically keyed dictionaries here today. We'll just be using records all the way through.
Is that similar to how it's done in JavaScript?
It's
where object sort of you have two notations, but they map to the same underlying data structure.
I need to check on that. I think it's similar to how it's done in C#.
But I don't know C#, so that's not helping me. Right. Sorry. I know Python. I know just enough JavaScript to be dangerous. I've read them.
Yeah. So I mean, when you move across to these statically typed languages, then you have to split the world, and it is one of the reasons why working in a statically typed language is a little bit harder in some ways than working in Python. You get benefits from it, but you have to split the world into what we statically know and what may kind of dynamically change. And in these, when you have a static type, like the one we saw for location response, it will be called a record, and it will have a static set of keys that don't change at runtime. And if it's dynamic, it'll be a different type called a dictionary, and they can change at runtime. Now, TypeScript is the leading language which kind of merges these two worlds together. F# keeps these worlds separate. You either choose in your coding to work in a static record, or you choose to work in a dictionary. But TypeScript is an interesting blending of this world.
That feels familiar from C++, which I do remember a few things about.
Mm-hmm. Got it. Yeah, and any attempt to statically type Python code is going to absolutely have to land in that kind of middle space, like TypeScript. Yeah.
Yeah, we do it very similarly as TypeScript.
Yeah. Right. We also saw some strings. We won't particularly go there with nothing particularly interesting, and we've discussed this now. F# is a strongly typed language. You can hover over things. The IDE knows your types and checks them on the fly. Excuse me, it's quite
You'd be surprised how good the IDE is for dynamic languages like TypeScript and Python.
I absolutely am aware how good that material is getting. F# is like on the spectrum of kind of how much typing it asks you to get right before it runs your code. It's definitely on it really checks your code and quite kind of deliberately designed to be tight, I guess, and to whereas TypeScript, for example, well, it has various modes. You can call strict mode and things like that. So.
Oh yeah. So if I sort of change this property name, it immediately complains.
Exactly. It wants to know.
Yeah. So I was wondering if we could sort of, I don't know what the term is, lift this match out. If we could put the match at the outer level and say, if there is no validation error, then don't generate a property, or otherwise, if there is a validation error, generate help with blah and blah.
Absolutely. Why don't you give that a go? I'll also, you should be able to flip.
Yeah, I'm not going to try to use the refactoring.
No. We don't even. In fact, one of the nice things about F# is that you can do a lot of refactoring simply by indenting and undenting.
Yeah, I probably have to. Oops, I'll done that a little bit.
Yep.
I didn't want that line there, and that looks like it goes there. Now, I don't see any squigglies. Let's see what happens if I save that. Where was my thing?
Yep.
It says invalid postcode. And now it's not invalid.
Yep.
Okay, well that's actually pretty nice.
Thank you. I think that does. We will. Excellent. I like it very much. The code is better. F# knows how symbols resolve. You just saw a rename, and so you can support this kind of refactorings. Which I'm with you, Guido. I don't use those refactorings that much. I do use rename refactoring.
And it's not really the language that knows how symbols resolve. For the refactoring, it's the fact that the editor knows, right? Or is that the editor and the language are still separate pieces of the world?
So when I'm saying F# knows, I mean F# is designed to know. The F#, so F# is symbol strong, you might call it, in the sense that it knows whenever you have a symbol in your code, it will know how that resolves, and it will resolve to something static.
Funny, interestingly, in Python, scopes of variables are about the only thing that is statically known.
Mm-hmm.
Like the Python compiler, if there is such a thing, doesn't know the types of things. It doesn't know the difference between a function, a class, or an integer variable.
Mm-hmm.
But it knows which variables are locals, which variables are globals, which variables are sort of part of closures, and all that stuff.
Mm-hmm. Yep. Understood. And it's interesting. Yes, it's we use these terms like statically typed or dynamically typed and so on, and actually prefer to kind of analyze different properties, just like you were saying. Like, how much does the language know about symbols? Okay, and it because it just doesn't cut the world into two kind of things. You can actually look at every different language and make that same kind of judgment about what it's doing. Okay, so we can now, we'll just look through a few more slides, run through them quickly. So the aim is to achieve three kind of things. We do want a kind of succinctness. You'll notice F# code is pretty succinct. You don't type annotate everything. It's got, if you strip off the lets, you can sometimes believe it's almost like Python sometimes. But we do get the performance of C# and Java because everything is ultimately statically resolved. And we do aim for, we sort of touched on that with this question, what do we mean by static typing and how much do we check? And those lines are being blurred all over the place today with languages like TypeScript and Python being typed and so on. But we want a kind of robustness and a kind of, with a tradition, I guess, that's coming from the strongly typed functional programming languages. We don't think of...
So let's clear up a misunderstanding. I somehow always thought that F# was in the family of functional languages, but you're not even mentioning that here. And
I mentioned strongly typed functional programming, but F#, all these languages support functional programming now. It kind of comes from a tradition of the functional programming languages, but that's not what matters to me. What matters to me is the properties we deliver and the experiences we deliver with it. Right. Yeah. And I actually
that makes sense.
I've actually broken a lot of the rules of functional programming, and along the way, there's a couple of talks I can point you to maybe, or we could talk separately about that. There's a history paper on the early history of F#, and sometimes, we deliberately did things differently because in some ways we're trying to we'll credit the Pythonic kind of spirit and to bring it into the functional programming world. We're also taking elements of the object spirit and bringing it into the blending that with functional programming point of view. We do keep this emphasis on immutable data, or what we call functional first programming, where the place you start is with kind of immutable data, functions, and working with those. Okay, but then you bring in aspects of mutation. You can do mutation. You can do side effects in F#. You put a print statement in the middle of this. I don't know where it will print to in a web browser, but you could do logging and everything. It's a lot of things. Yeah, and we bring in object. So I mentioned object programming. So some functional languages like Haskell haven't really had their full reckoning with object programming. They haven't really kind of worked out how to combine the two. F#,
Well,
we've done that.
it's sort of, yeah, there are corner cases of the type system that are deeply affected by that, right?
Absolutely, and the major, probably the biggest part of F# is delivering a type system that kind of blends these characteristics while keeping this, well, to deliver these three key things. I just scroll down just to orient people. This stuff will be familiar to you on the slide. So this is our structure here. Some of the code in index.fs is the web client. It's actually being compiled to JavaScript. And so you're writing JavaScript in your, you can see on the top of the bar of the editor, you'll see index.fs is your current file. And this is getting compiled to JavaScript. And if anything in api.fs is getting compiled to .NET. And shared.fs is actually shared code between the two for validation code and things like that. So F# is absolutely a JavaScript language as well. The JavaScript tooling is provided by the F# community. And you could say marks in terms of delivery, we all contribute to everything. The .NET existence of F# is delivered and curated by Microsoft at full enterprise quality. Okay, the architecture we're using in the web client is called Model View Update. It's MVU. It's a bit like React. There is underlying is a model. It's got a view function that generates the DOM, and then that DOM gets applied to the actual DOM. Like the diff gets applied. And then you get a dispatch function which sends a message. It goes around the update loop, and it goes round and round and round. The important thing here is the view function is which you've been editing the bits and pieces of the ultimately packaged up into the view function. It's just a function that takes a model and computes a view, and it's just functional programming. In a sense, you calculate the view you want. So in lines 3 through 8, where we did that pattern match. And then you did your modification. You are calculating the DOM components you want, given a particular state of the UI. That whole thing is just a functional calculation. When I say calculation, I mean kind of, you know what I mean. It's just a pure function.
Yeah,
it's just
It's sort of starting here, like that destination entry section. That just describes a piece of HTML.
Exactly. Right? In fact, if you go to the bottom of the file, you will see the complete view function. That's it here. And it should add up. If you open up the app that we have in the browser window. This one here. And the structure should sort of matter. It should match. We have a model coming in. We have a dispatch function, which is a function which allows us to dispatch, and that's at the top of the view function. The arguments to the view function on line 436, and so on line 436. So you see we've got a model.
Takes a model.
And the dispatch is a capability to do dispatch. It's a function which you can dispatch new messages with.
Okay, that part of the syntax is not super clear to me yet.
Okay, so the view is a function that's being defined, and it takes two arguments. Okay, it takes a model and a dispatch, and
so I'm confused why the model is in parentheses and the dispatch is not.
The model is in parentheses because it's got a type annotation.
Oh, that's so different.
Yeah. So it's because
in Python you would just put parentheses around the whole argument list.
That's right. So a lot of
I see. Okay, I'm getting the syntax now.
Cool. Great.
Yeah.
In fact, why don't we take this as well? I was just going to mention is if you look at these lines, I guess line 445, line 448, line 452, you can see us laying out the destination entries. And
then, here's a for loop that I guess the destination entry is the sort of the input box where I type the zip code.
It's the whole of one of those boxes. Yes, that's right.
Yeah.
And we always on line 448 we always add an empty one at the end.
Okay, that's where you add more.
Okay.
I see.
And then on line 4,
Okay, so
5,
I see what you mean by that. The sort of it's comprehensions on steroids, because you have a comprehension part here. That's those 2 lines.
Yeah.
And then you have just one extra entry.
Just an extra one. That's right.
And in Python, you'd have to use a star and some extra parentheses to do this, to sort of combine that.
That's right. And and so some of these languages have these generators, which are very good at doing this sort of thing, yield, or whatever other syntax they use. And I know Python has things like this too. So this kind of combines comprehensions and generators into one.
I'm confused actually why there's a yield here and not in the other places.
This one has a yield bang. This is because it may produce, the way destination info section is written, it may produce multiple entries. If you want to yield, so destination entry section just yields one element. But if you want to invoke something to yield multiple elements, you've got to make the yield bang explicit. Okay, if you look at the type,
are you saying that we don't really need the yield here? Could I just get rid of it, or will it not work?
It won't work, because you will be told, hey, this thing, the syntax is telling me this is yielding one element, but this is actually yielding multiple elements. So you can take it out if you like and see the error that comes up. I probably regret how bad the error. Yeah, okay, the error is not that great. Could you put that back in? that error message is not the best in the world.
Okay. And so we don't need that in the previous, the first section, because what exactly?
If you hover over destination entry section and take a look at its type, you'll see that it's
React element.
It's producing a React element. Now do the same thing for destination info section. You'll see it's producing a list of React elements. Okay.
Okay. So the yield, in a sense, is sort of flattening that list.
Exactly. Yeah.
Okay.
Yeah. So you kind of got to. Yeah. Cool. That is great. We've covered a lot of topics that we're actually doing.
I think we're not going to get to task 5, right?
We will get to task 5 because we will skip task 4. So let's do task 2, and I'll take a glance through the lessons along the way.
Okay.
And
one problem: we would like to add maps for each stop.
Yeah.
Whoa. There's also a weird thing here that I think that is just because the line is longer than.
Yes, it shouldn't.
Yeah.
That shouldn't be there. You can delete that. Those 2 characters out. Yeah.
I thought it was funny extra syntax, but then I realized it was green and there was no line number. Okay, so what do? We add the map widget. Well, I'll just type map, and
it does tell you what function you will need to use to create the map widget. If you look at those instructions, it gave you a bit more information.
Yeah. Map display.
Yeah.
Okay. So this is like, do we just add it like that, or do we wrap it in? Like, I mean, up here I see things added in columns, and again my HTML is rusty.
This is not HTML. This is a DSL, F# DSL for HTML.
Yeah, I know, but it maps to HTML, and so, yeah. but that, for most people that is helpful, but for me, you still have to explain what the structure of the syntax of the DSL is, and so I'm just going to type map display and.
Yeah, so 415 gives a pretty good guide, which is where line 415 gives a pretty good guide to the sort of thing we're going to want. So that's laying down a React element for the location display.
And we can give it, we can use location again. I don't know if a location is a location response, though.
You can, if you're interested in knowing, you can hover over on line 415 and check out what the type of location is.
I have some kind of Git thing.
I don't know why it's in it, but at the bottom it does say location response. Yes, there's the val location.
Okay,
is
okay. Well, then I'll just type that.
Grand.
And now I'm curious, is that all we need?
That is all we need for task 2.1.
Okay, and now we have to refresh or not? Oh, wow, and it shows a map for Madrid. So,
Okay.
wow, fascinating. Do they all show maps for Madrid, or? Oh yeah, the map widget needs to be told what to.
And you've predicted what task 2.2 is.
Oh, well, let's go to the definition of map display.
That's fine.
There's the task 2.2.
Great.
It's the pigeons map.
Yeah, we're using a pigeons map.
I don't know what a pigeon is, but
I don't know what a pigeon map is either. I cribbed this from another dojo that the community developed.
You know, what does the word dojo mean? My teenager goes to a dojo and they practice martial arts there, but I don't know that this doesn't feel very martial what we're doing here.
Okay.
Or maybe it is. That's the battle of the language designers.
No.
Map.center. We have an LR dot. Probably that location again. And I made that same mistake again. Yeah, does not look like it likes that. Oh, it wants a lat long. How about that? No.
Okay, so take a look at the map.center function and take a look at its type. So it wants two arguments, latitude and longitude, and it actually wants them in a tuple. And so if you continue on with dotting
and
through,
lat long is not a tuple.
Lat long is you can dot through it and see what else it's got. Well, yeah, and you can look at the definition.
Oh, your naming convention tripped me up here, or is tripping me up because you're using capitalized words for values as well as for types.
That's right, for properties as well as types. Yeah.
Or yeah. Okay, let's see if we can find our way back to task 2. Okay, so. Well, how do I make a tuple? I just created, put it in parentheses.
Right. And commas. Yep, that's right.
Commas even. Oh, that's the first comma I've seen in the entire program. Wait, what? Man, I wish that there was an X and a Y instead of such long words, but that's an API. Yes. Well, we can save that and see what happens, right? Oh, I refreshed and now I have to go again. 2013 is Haarlem, and 1791 was Texel. Oh, I didn't fetch that. And there's Haarlem. Okay, yeah, there's Haarlem. The scrolling is that we don't care. And there's the beautiful island of Texel, where I spent
wow,
a few days with thousands of other German tourists. Okay, task 2.4.
2.3 is there. You might want to do that one. That takes 2 seconds to do.
That update the zoom to 15. Really?
Those were a little bit far, so that will.
Oh.
Okay.
Oh, I see.
Okay.
And task 2.4, create a marker for the map. What is a what is the visual effect we're looking for here?
So it tells you the function to use. It's a bit similar to when we created the map itself. You can use the make marker function. The make marker function is defined immediately above.
It also takes a lat and a long.
Yeah, exactly. You can just copy that out. Exactly.
I'm gonna randomize it a little bit. Let's see if that is noticeable. I have no idea how much that is in meters.
I think that was good. You just put it off. Yeah, you can fiddle with that. Yeah.
That is probably going to
I think that
be very sideways. Yeah,
off the map. Yep.
yeah. Aha. Okay.
Okay, so that's a bit of eye candy.
So we played around there. That's always good.
Just to recap some of what we saw in task 2, you've been making this functional data. We talked about computed list expressions actually in task 1, and that was in task 2. We actually saw various bits and pieces of computed list expressions, and you saw some tuples and some helper functions. Let's take a look at task 3.
Okay, in the search bar we go. Oh, that's a very structured task. We want to start with 3.1a, I'm guessing.
Okay, we're going to add a weather display in here.
Oh yeah, that's exactly what I'm interested in, actually.
Okay,
yeah, we've
good.
been anxiously looking at the weather to decide what to pack.
So some of the weather response is actually done. The server will need to be updated to actually give across these weather responses, but this is the type. It's in the shared code between the client and server. And we have a type for a weather response. So this doesn't actually need a change. It's more to orient you to what your application
code. A weather type and an average temperature. Okay.
Yeah.
That's what we get from the weather server.
Yeah, and you can see some of those types up above. If you want to scroll up, you can see, for instance, weather type is here. And it is, in fact, a discriminated union between the different kinds, or an enum between the different kinds of things that the weather server produces. And you can see the code to parse and to convert those between the forms that the API coughs up. And those have been
what is the part? Tell me more about this parse thing.
Parse function. The way it's written is it actually uses some reflection. So F# is a little bit different to other statically typed languages, and we do allow people to do things like reflection. And so it says, take that, you see the type of weather type. It says, get me the union cases of this type of weather type. And type of gets you the reflected.
So weather type here is just that thing.
Is that thing there? Get union cases.
Get union cases is built into the library.
Exactly, and it says get me all of those
and I imagine the compiler actually knows enough about this get union cases thing that it just sees the weather type right there and says, I know what weather types is, or?
Actually, it's not done at compile time, but the way the person has written the code, I didn't write this bit of code, but is to compute those once and then return a function on line 31. So let weather types will be computed once, and then you get a function which then takes those weather types, and now this uses pipelining, which we were going to meet in another construct, but we may as well do it here. It says, work your way through those weather types to find the one that matches the string, except it also does some hacking to replace spaces with empty.
Okay, I don't know the priorities of the operators, so I can't actually parse the argument to find. I see fun and an arrow and an equals, and I don't know.
So fun
what is what.
Fun.
I'm sure that's a lambda function.
That's fine. Could you? Yeah, that's a lambda function, and W is the argument, and then the arrow points to the expression that.
And so my question is all this sort of
that's one
the return value
exactly.
Or
yeah, it's
okay, so it's not grouped like this.
No, that's right. It's one Boolean typed expression.
And and the other thing is this single equal sign is actually an equality comparison.
That's right.
So, that's going to take some time getting used to since every other language uses 2, huh?
Exactly, that's right. So it does.
Okay, so there's a find function which is part of the array data type, which takes a lambda argument that is a selector.
That's right. So it's fast. So
and it essentially looks for things whose name equals S except with spaces removed.
that's right.
Okay, so maybe there's a string that it would be light space rain, and that will map to that. Okay, and so weather types must be an array. Where did it say that it was an array? I guess that's the sort of the type of get union classes.
That's right, a union case info array.
Okay, union, and when it says here, oh, I can't point. Oh well, when it says union case info array, that's sort of, that means an array of union case info.
That's right.
Okay, and so now the pipelining is we select items in weather types and we still return an array, but it has fewer elements in Python.
Array.find actually returns the first element that finds.
And so then it's no longer an array. I see.
That's right. So and then it pipes that into a new lambda, which it consumes the result, which is called U on line 34.
Oh, and so that U is the first thing in the array.
Mm-hmm.
And why would we want that?
It's a union case info, and then we actually want to we've got the reflected info.
I see. That gives us the whole union case info.
Yeah.
And then we use the reflection again to
we actually make the value. We actually we go out of reflection back to normal values. So we actually say, give me the actual value for that union case. Okay, so we get a weather type value. We cast it at the end. That's that funny colon question mark greater than operator. And in the end, we get back
that to thing is a cast.
It's a cast, because when you're working in reflection, you're just working in the world of object and type object. It's not strongly typed. Mm-hmm. And then we're getting back to the strongly typed world.
And so what we're getting back is a union of U or the empty union.
That's an empty array.
Oh, an empty array.
And so we're actually making the union, but in F# and like other functional languages, the discriminated union, the values can carry data as well. In this case, none of them carry data. So if we look at snow, sleet, hail, thunder, none of them carry data. So that's why that's empty, because we don't.
Oh, the empty array is just the data that goes with you.
That's right. The objects are coded.
So make union doesn't make a union type, as I naively misunderstood the language.
No, it makes
it makes a value.
That's right, a union value. That's right.
It makes a union value, which apparently all union values must have some kind of uniform runtime representation so that you can safely cast it back to weather type.
Exactly, that's right. And it's checked at that point. So this is it's kind of a bit of typical F# reflective programming. Kind of, you go into the reflective world for a while, then you go back to the strongly typed world. And it's actually
the reflective world, is that still happening at runtime, or is that actually running in the compiler?
No, it's happening at runtime in this case. You could pre-evaluate some line 30. You're right. It could be pre-evaluated, but it's not.
Okay. So
and then we'll do.
We haven't actually done anything yet.
No, that's right. This was
the type
orientation. You don't have to do anything at this point. But if
now we go to 3.1b. When we fetch data from the server, also get the weather.
Yeah. So you want.
So now we're updating the type.
That's right. So you're adding some more to this record type.
How about that?
That sounds great.
Is weather a good name for it? Well, it seems consistent with what we have before.
Could you go down to problems now? If you look at the bottom tab where you have your debug console and
there's a problem indeed.
Okay, so you can single click on this, and it will say you are missing some data here.
That's nice. That sort of. That problems tab exists for Python 2, but I never use it while I'm coding. Basically, I use it to sort of make a separate pass to get the types right if I use it at all.
Yeah.
Here, of course, it's always directly relevant.
That's a super useful. You have it open, and your game that you're playing is to get down to 0 problems, and then you run.
Yeah,
okay.
it's almost a little. I don't know. It's not enough in your face, but that's for the VS Code UI designers.
Exactly.
And I'm sure they will just tell me, oh, there's a CSS property you can change to make it red, and then I'll go, oh, sure, never mind. And I'm not gonna not do that. So what was our task? Return the weather. Oh, I just have to fill the weather field, but I don't know where. I probably have to let weather is something first, right?
You can fill it in and get it undefined. Yep.
Yeah, and then I don't know. Probably here we.
Yeah, you can copy that line and adjust as appropriate.
Okay, let.
Your indentation is off by 1 there, and that will matter. Yeah.
Oh, that's weird. Oh, your comments are indented more than your text.
Exactly.
Oh, that's like nasty.
Yep.
You don't have to do that, right? Comments don't have. What is the policy about indentation, by the way?
So it's indentation aware. That's why you need it. That's why the language looks quite Pythonic in some elements of it. Yeah, so the comments are ignored during indentation analysis.
Get weather. I don't think that I did that right.
You can look at the argument to the type of get weather. It takes some string. It takes a string to an asynchronous weather response. We'll talk about AC in a moment, but essentially you need to pass the same string as got passed to the location request, which is
destination text.
Yeah, so it's the text typed into the destination box. Okay, that's task 1.3c, and you should be able to save that now. Nothing's going to happen because we haven't updated the visuals yet. So in task 3.2, you can update the visuals as well.
I see. Add a second column so that it would be where. We can also skip that because this seems like
it's a
unless there's a new language feature, it seems like we're just sort of twiddling the UI, and
exactly.
That is
fine.
the least interesting part of coding.
That is totally fine. And in fact, what you just did got us to the main thing. If you want to fill in the temperature here, it's a very similar thing to before. And in the learning sequence, we would also get to something that shows a bit more about pipelining, but we've already seen the pipelining when we looked at the parse function. So users watching can do these parts themselves. That's fine. What I did, if you go back, navigate back to where we had, back one more to task here. So you'll notice that this is actually an asynchronous function. If you notice at the end of 94, it's formatted perhaps a little bit. You can see the inferred type on line 94, the little bit in gray at the end of the line. That's added by the IDE automatically. It says it's taking a string and it's asynchronously returning a server response. So this is how asynchronicity. And you can see the get location is also an async function, and you use let bang to get rid of that asynchrony. So let bang is like the await syntax.
Oh, that's our await. Yeah.
And then on line 101 is a similar thing with calling. Okay, so
Is there any particular reason for the choice of bang there?
So async is in fact not built into the language. Async is a very example of a very general construct called computation expressions. And in fact, the lists that the computed list expressions are also a version or example of this computation expression, which is configurable. You the async thing configures what the let bang does. And you can actually have a whole range of different things which configure the syntax in a way, statically configure the syntax. And this lets you have asynchronous programming. It lets you have asynchronous sequences. It lets you have computed lists. It lets you have.
This is like sort of modifying the compiler, or it's, I don't know, compile time libraries or something?
It's specifically designed to have no, it's not extending the compiler. It's all done in libraries. You define
is it a macro system then?
You can think of it as a local rewriting system. Yeah, it is. It locally rewrites this. Async kind of is in charge of kind of locally rewriting the code statically.
And so the scope of what async rewrites is everything within those this curly?
Exactly. That's right.
I don't know where that ends, but let's say
it ends on one. Exactly. That's what it is.
Yeah.
And it doesn't have many rewrite rules. It provides a set of it basically gives a set of methods which tells you how to stitch the code together. So how to implement let bang, how to implement a while loop. So because you might want an asynchronous while loop, how to implement a for loop, you might want an asynchronous for loop. And so
and so your compiler has an API for those things.
No, it's got a design pattern. Async is actually a value. It's an object which has a set of methods which tell you how to stitch the code together. It's called F# computation expressions. And the compiler does know how to. We've recently been doing work to make that as efficient as C# tasks and other asynchronous programming. F# actually kind of originated this asynchronous kind of thing with this construct. You can read about the history. We started this in 2007.
That's what
that went into C# in other versions, and so. Yeah, this idea of kind of taking the existing computation syntax of the language, but actually giving it a very different interpretation and making that configurable. I mean, F# makes it. See, you can also configure the C# syntax in some ways, yeah, it's a super powerful construct, and we use it for tasks. We use asynchronous sequences. We use it for computed lists. We use it for parser combinators, and a whole range of other kind of computation expressions.
And so let bang is just like, it's the variant of let that this design pattern is allowed to overwrite.
Yes, if you go async and then if you hit dot after the word async, okay, because async is just an object. And then you'll see its different methods. And the first one is bind, and that is actually let bang corresponds to the bind operation. And the bind operation stitches together, and you can see the other things. You can have try finallys in async blocks. You can have try with. You can have while statements, and those are asynchronous whiles and asynchronous try finallys, and so on all the way down. And each of those are the function that guides how the async implements that construct. And you can write your own. Actually, people do this. There's an excellent guide.
And because everything is statically typed, the compiler sort of. I'm still curious how the compiler sort of. How much of the definition of async the compiler needs to read in order to know what to do here?
It knows it all, and so when it comes across the let bang construct, it says, "Oh, the builder on there." So that's called a builder async has to have a bind, and if it doesn't have a bind, we're going to fail compilation. So, for instance, if you tell you what, after line 95, somewhere like put in a new line and do yield space 1. Space 1. Okay, so now you get an error, and you see the error. This control construct can only be used if a computation expression builder defines a yield method, and it doesn't. You can't just. If it was an asynchronous sequence, it would have a yield method, but it's not it's an async, and you can do a return, but you can't do a yield. Okay. So, okay, so you can see on line 110 where we return the overall result. Yep.
So there is in fact an API that async has to conform to.
There's a design pattern, you might say. Yeah.
Why is it not? Why do you not call it an API?
I guess because it's actually a whole range of different design patterns depending what you do and don't have. I would guess you might call it a compiler known design pattern. C# actually has quite a lot.
Sorry, what was that word? Compiler something?
Known. So a design pattern that's known to the compiler, that the compiler explicitly looks for. It's a bit like disposable in C# and F#. It looks for.
Oh wait. Well, again, I don't know C# enough to for that to help me. But when you say design pattern, I think that means like a set of method definitions that follow certain I don't know, requirements.
That's right. That's right.
Okay, and not calling that an API is because API in your world already has a more precise other meaning.
Yeah, an API would be a package or a library. Yeah.
Okay. Well, yeah, sort of in the sort of less formal definition, that totally sounds to me like an API, but
okay,
I'd be happy to call half of the things that I call APIs design patterns.
You could call it, some languages might call it a protocol or a thing.
Yeah. Okay. Yeah. Got it.
So we're going to change modes a little bit and use the F# REPL for a little bit, because in this last part, we're just going to explore the use of a different web service that someone who's watching this might want to extend the application with. So the first thing we're going to do is just do the hello world of the F# REPL, task 5.1. You can just type in 1+1, and it uses a send to interactive mode. So if on line 18 you type 1+1, for example.
I just type here.
Yeah, exactly. Just type in 1+1, and then you 2 + 40, and then you highlight that code using your keys or your mouse.
Oh yeah. It's not that interactive.
And then you do Alt Enter, Alt Return. Yeah.
No, sorry. That was not the Alt key. Okay, there we go.
So you can see it's entered 2 + 40, and it's showing
the answer is 42.
As it is. Okay, now we will take a look at a REST service you'd like to use. If you want, we're going to skip task 5.2, because this is where you just basically look at what this REST service is giving us, and you'll see it says find nearby Wikipedia JSON and api.geonames.org. So this web service actually just returns us some JSON with some interesting points that are nearby a particular latitude and longitude. And you can see the latitude and longitude has been in that URL. But we don't need to click on those URLs because we'll skip through that. But basically, imagine you've seen a bit of JSON that comes back as a result. Now we want to take a look for a package. So if you could pop along to your browser and go to nougat.org.
I've heard a lot about that, but I've never actually had an opportunity to use it. So let's see.
It's a package system package manager, and if you type in f#.data into this, it is a good package for doing web requests and
like
for f#.data. You'll see the top result there is, you can click on that there, and you can actually click on script and interactive in those tabs where it says package manager, .NET CLI, package reference, packet CLI, then script and interactive. Just above. That's it. And you can copy out that text. That's it. Copy that across, and don't type it in the REPL. Keep it in your document up above. F# is a very
we put it
that's
here.
Fine. That's fine. Yep. That's fine. And you can highlight.
Sharp character mean?
That means hash is like a meta command, like extend the static environment. It's kind of static because it's still a static language, and so you have this hash reference or hash load. So things that are done. Like extending the references you have. So you can highlight that and execute it.
Oh, I can't just type it down there?
You can. We don't use that mode in F#. I mean, people can do it, but it's more like a notebook. And in fact, we can talk separately. F# supports like Jupyter notebooks and the like, and you can use it in VS Code. One of the things I'd like to notice.
Something.
Yeah, it's got the package, and you've referenced the package. Yeah. So one thing I'd like to call out here is it's got the strongly versioned references in scripts, so your scripts can pin down the exact version of packages that they depend on.
For better or for worse.
Yeah, and they can also you can leave it undefined. You can say bump to the latest version if you want. And you can also pin down the exact .NET runtime that is being used to execute the script in a separate mechanism called global.json. Okay, finally, we're going to crack that web service, and we're going to get some types for it. So I've actually given you the code for this in task 5.4, where we open the open is like using or import.
I see.
We call it open. And we now have okay, so this is using a great feature of F#. It's called F# type providers. And F# type providers allow you to point to an external resource and get a strongly typed API for that resource. Okay, so in this case, we're giving it a sample from this web service, and this is you can take that URL if you like and paste it into your browser. So we can take a look at the sample that we're getting. So you're looking at a JSON browser of it. You saw that you could click on the raw data tab at the top to see the raw data.
Okay. Yeah.
So you can see this is the input to this. This is a compiler extension, and it is giving us strong types over that API. Okay. So at compile time, that means if you compiled this script, it would actually go and make a request to that web service to get the sample and use that to guide the generation of types. Okay, so this, yes, it's a.
So if the sample doesn't include a certain optional field, it will not know about that, right?
That's exactly right. Now, fortunately, the way these REST APIs are nearly always documented is to give you a sample URL which shows the
full output, basically.
Yeah, the full possibility. Yeah. Okay.
It sounds like that. Sort of the APIs need to be designed in conjunction with the concept of generating the API from the example.
You can also give JSON text instead of the URL, and it will use that instead. So you can pin down your schema.
Okay. Yeah. Well, that would be a lot more text.
Yeah, it would be more. It would be more text, but it's sort of more. There's a trade-off here between.
Yeah, it's sort of. You see what you get at least.
Yeah. Okay,
yeah,
so
tomorrow
now
that server could stop working or send something else.
Exactly, that's right. Sometimes in experimenting, we do this, and then you pin them down later. Okay, 5.5, you can uncomment this code here. We've given it to you, and this is just giving exactly the same URL, but we're actually using that API to actually load the data. Async run synchronously says get rid of the async and actually run the async thing straight away.
Okay,
which is appropriate for a REPL, and you could.
So could we have done that with a let bang? No, because it would have had to be inside
that's right.
an async thing. Yeah, we have exactly the same sort of end condition in Python where there's also like async io.run.
Yep.
Sort of
that's right.
to drive the thing at the top level. Okay.
Yep, that's right. Okay, so you can run that code.
What do you want me? Did we run this yet?
No, I don't think so. So it doesn't matter. You can run it again. Okay.
And then this, and I want to look in what we get in info. Oh, it already tells us.
That's right.
And then it just truncates because there's too much.
Yeah, and in fact, it's doing the nearby Wikipedia points for Amsterdam, and we're showing the Jewish Historical Museum in Amsterdam, for example. Yeah, Frank House and others.
I remember that place.
And finally, in task 5.6, we'll just extract the information we might want to add to the application. So we're going to use one of these computed list expressions to do it on line 57. And you can run that code, for example. And you'll see the 5 different places near postcode 1011.
Okay.
And
no idea what the Marken plane is.
Okay, well, I tell you, why don't we
in the last 25 years?
Yeah, why don't we find out by returning some more information? So the task 5.6 has asked you to get the title, the latitude, the longitude, and the summary. And you can absolutely just use commas now. You have full permission to use a comma, and you don't even need the parentheses in this particular case. You can just,
Yep. This API is a little, that doesn't really help me much, but.
That's
Let's
it.
just run it.
Okay.
Oh, I bet you it's LOM.
LNG. No, once it actually gives you a hint there. In the red text, it says LNG. It says maybe.
What?
Yeah.
Okay, well, this is clearly not your fault.
No, that is not our fault. And
Let
you cannot.
LNG really?
Yeah,
What were they thinking?
If you look at that's coming from the JSON, right? We're getting that symbol.
I know.
Getting our symbols from the web, and the web tells us what is what. So you can actually add the summary text at the end, x.summary, to that list, and we'll find out what the marking plan is for your if you happen to be going to Amsterdam on this trip. No, yeah,
I'll probably avoid it, but
right.
okay. I think I have an idea what that is.
Okay, and we have reached the end of the tasks. I'll just recap what you've seen in tasks 5.5. And you have learned about evaluating code in the F# REPL. You've also learned about referencing a package with a strong version and finding packages to work with. And of course, packages can be added to your compiled projects as well. You've learned a little bit about F# data and how to use it with a sample from a REST API, and what is a little bit of an intuition of what is a type provider and how it gets symbols from external data or get your symbols from the web. And you've also just learned about how you can use the REPL to start to explore data in preparation for adding it to a backend service, and then maybe creating markers for those locations on your map. Now in the REPL, yes, very good. You actually need 2 semicolons. It's a relic of the origins of F#. That is.
Okay.
Yeah.
Now I know why you recommended that I not try that.
We've always taken a document-oriented approach, which fits so well with this notebook kind of programming. And I have to say just a huge thank you. I will just show a couple more slides. I'll flick over, actually bring up these slides on your machine so I don't, thank you. We can keep scrolling because you'll see it goes through tasks 2, tasks, what I read from before, task 2, what we learned. And
yeah, we talked that over.
Talk those through.
Tuples.
And we talked a little about task 3, pipelining, async. And you would have learned about string interpolation with some strongly typed string interpolation, but we skipped that, but we'll leave that for the viewers.
Sure. Cheerful functional data, huh? Yeah, you've missed a career in marketing there.
I think so.
Listen, task 4. Okay, we skipped that, but that looks pretty okay. There's a completeness check on pattern matching. That does not surprise me. Method and property members. Yeah.
Yes, so we would have seen a little bit more object-oriented programming, object programming.
And 5 was the REPL.
That's right.
And
that's right.
Importing packages. So if that open statement, which seems to be the sort of the import syntax, appeared in code, how does the compiler find it? Do you also have the #R line in there for the benefit of the compiler?
Exactly. Both C# and F# use the same model, and we separate out the package references. In a normal, so the #R is like a package reference, and all your project file will have a package reference, and your open is opening a namespace, and so we separate those things out.
Okay, so the sort of this line, the #R line would occur in a different file that's part of the project configuration.
That's right. If you just open a new file, we'll find it. You can go server.f. So actually just Control-O to open a new file. And go into the, where is it? Scroll down to source, src. and then go to server, for example, and go to server.fsproj. This is, and you'll see, yeah, I know, excellent.
Yeah,
So,
we have this stuff in the Python project too for Windows.
Okay, so this actually doesn't include a package reference, but on line 14 you can see a project reference, which gives reference to another project in the solution. But you can also have a package reference, which would say package reference F#.
Okay.
Yeah. So this is the metadata that drives the build system. Yeah.
Okay.
Now,
so that really is a sort of a different level from the language itself.
Yes, that's right. Yeah. That's right. And it's useful for F# because we get to use, generally in the .NET manifestation of F#, we get to use what C# uses, and that's quite useful, very complete. And but the viewers are going to be killing me for having shown you MS Build, because MS Build is good, it's not too bad, but it is XML, and we are in the 21st century. I know. Okay, so if we flick back to the slides, and we'll go through the last couple of slides just to recap a few points and see a couple of things. So we'll just keep scrolling down until we can get through them all. There were some further discussion points. We've actually come across some of those already. So 2, we did sort of unboxing to objects, sort of, or at least we did reflection, and you got the idea a little bit that you can leave the strongly typed world and go into the much more dynamic world through these objects. You can also have mutable data, let mutable XYZ equal 3 and change it. F# is not a pure functional language. You can drop down, you can and you can do that's why you get high performance programming. You don't have to be functional all the way. Other topics we won't particularly go through, sort of namespaces and modules for code organization. I do want to emphasize F# is, some people think it's absolutely not like a lazy functional language. It's not even really, it's not as functional as people think.
I got it.
Okay. Yep. Sometimes people make that mistake. There's a lot of important interrupt questions, which we, like how do we interrupt to .NET, how do we interrupt to JavaScript, and one exciting thing, which is literally just coming through the works, is that Fable, which is the JavaScript compiler that you've been using all the way through to run your code as JavaScript, it now actually includes a Python transpiler to generate Python code for F#. And so the more metadata we get from the Python world, we can actually start to have components or projects which actually generating and targeting Python. And and if you can give us some metadata, especially
tell me what you mean by metadata.
We need names. We need whatever statically known about. So let's say you take NumPy. We want to statically be able to be told in a bit way like a TypeScript file, a .ts file tells you what a JSON. What a JavaScript library gives you. We want the same thing for Python, as much static information as possible.
What you're looking for is typeshed, which is a repo in the Python world that has definitions for many libraries. I don't think that NumPy is there. There is a more general concept of a type stub. I know there are people working on stubs for NumPy.
That's right.
At the moment, we're struggling with some features that we need to add to the type system before you can describe more useful things of NumPy.
I mean,
but your compiler should be able to start reading those stubs already.
That sounds great. Now, I'm not actually doing the F# to Python transpiler, but absolutely, the Fable people who've just started to work on that will be, I'm sure, super excited to be bringing F# into the Python world as well, and to have components. So we love to interoperate in F#. We do that through a whole bunch of different means, whether it's libraries or whether it's transpilers or whatever we do.
Cool.
I have included the information that we haven't used a .NET Interactive or Jupyter Notebook. I did think about using that as the way we would do the teaching, but I thought it was a bit more fun to take you out of your comfort zone and get you into the web programming kind of space. And I think that was...
Well, notebooks are also completely alien to me.
Okay. Yeah, right. So that good. And
just as well.
I have also just included a little bit of machine learning code because Python has got obviously a lot of association with the machine learning world, just to show you that thing about how Python and F# are actually quite similar to each other. So just to take, this is a Python GCN, which is a convolutional network. The G stands for, sorry, I'm having a brain blank. It is
whatever it is. Here's the F# version.
Yeah,
and
that's right. Pretty generative convolutional
it maps almost line to line.
It does, and you just take the let out, and things are very, very similar. You just a few changes all the way through, and a couple of little bits of difference in syntax that people get used to. And that, I think, is the last slide we have. And the next slide will just say a huge thank you to you, Guido, for the time you've given the F# community today and the programming languages community. And it's been, and .NET Conf, it's been an absolute pleasure to have you.
It's been great to learning a new language.
I'm glad you have enjoyed the day. And we wish you well on your trip to Europe. We hope you discover old places, new places, and have a wonderful reunion with your family.
That's the plan.
And friends, which we're also longing for after what's been going on. So thank you again.
Isn't that the truth?